In example number 4, I'm asked to find the perimeter of a pond. Now we have to first of all understand what the perimeter of this particular pond is going to be. It is this straight edge that goes from A to B, and it is also going to be this arc which goes from A all the way around to B around this line that has been marked C. So we've got the measurement from A to B, and you can see that the measurement that I need to get is that major arc, which is represented by C. Very often when working in this section, there are 3 other formulae that you need to resort to. You might remember these formulae from trig. So there's the area of a triangle, which is a non-right angle triangle, which I could use. Remember, if I want to use this one, I must have the information given to me as side included angle side. Then there's the sine rule that I would be able to use, and for that I would have to have 2 sides and an angle, or 2 angles and a side. And then lastly, I could use the cosine rule. For this one I need to know 3 sides to find an angle, or just like with the area rule, I would have had information given to me as side included angle side. Now in order to solve this problem that's been given to me, I'm going to have to use the cosine rule. Using the cosine rule, I'm going to find this angle over here. Once I've got this angle, I'll be able to find the other part of that angle which makes the revolution. So going to the cosine rule, we're going to now find that angle, and I'm going to call it angle O1. Now I write the formula as follows. The side opposite the angle that I want is AB. So it's going to be AB squared is going to be equal to one of the adjacent sides, AO squared, plus the other adjacent side, BO squared, minus 2 times AO times by BO, and that must be all times by cos of the angle that I want, which is angle O1. Now filling in my information, I've got 2 comma 4 squared is equal to 2 squared plus 2 squared minus 2 times by 2 times by 2 times by cos of angle O1. If I change the subject of the formula so that I can get this into standard form, I'm going to have it as follows. Simplifying this expression, the numerical ratio on the right, I find that I am in fact going to have in standard form that cos of angle O1 is going to be the numerical ratio of 7 all over 25. As this is a positive ratio, we know that this is going to be an acute angle. And so solving for angle O, I find that angle O1 is in fact going to be the angle 1,287. Now, if you got an angle that looked as though it was something in degrees, then you forgot to change your calculator so that it was in radian mode. My calculator was in radian mode, and so this angle looks perfectly correct. How am I going to find this other angle, which is the angle O2? Well, we know that a full revolution is 2 pi, and so if I take 2 pi and I minus angle O1, I'm going to get angle O2. So O2 we have found is going to be the angle measured in radians of 4,996. As I've got the angle and I've got the radius, I'm now able to find the arc. And the major arc that I am going to find is the arc C. Finding the arc C, I'm going to say that the arc could have been found if I'd taken the radius and timed it by the angle. In other words, that is going to be 2 times my angle of 4,996. So the arc length for this pond is going to be 9,99 meters. If I wanted to know the whole perimeter, I would therefore take the arc length of 9,99 and I would add it to the two radii, to the length from A to B, which is 2,4. And so adding these two lengths together, I find that the whole perimeter is in fact going to be 12,39 meters.